Hi, Algebra 1 students. Welcome to Week 8, Simplifying Rational Expressions. So a rational expression is a fraction whose numerator and denominator have polynomials. And we've dealt with these before, especially when there's a monomial at the top and the bottom, but we're going to talk about other polynomials in the numerator and denominator. When the numerator and denominator so you simplify a rational expression when the numerator and denominator have no other factors in common other than 1. All right, so these are the ones that we've seen before. So these you'd be using your exponent rules. Remember, when you're dividing your bases, you're going to subtract the exponents. Subtract the exponents. Okay. So for the first one, so I can divide out the numbers. So I can divide out the 3 and the 9 and divide them both by 3. It gives me a 1 and a negative 3. So that's what my numerator and my denominator are when it comes to the numbers. As for the exponents, that's when you're subtracting. So 3 minus 0 is x to the third in the numerator. And then for the next one, 4 minus 6 is a negative 2, which means I'm going to have 2 of these, and they're in the denominator. And then you technically don't need that 1 there, so you might see on answer keys something that looks like this, without the 1 there up at the top. For this one, I'm going to simplify what's inside first before I share the 3 with everything. So 2/3 stays as 2/3. But then I'm going to simplify my x's and simplify my y's. If you don't see an exponent, remember the exponent is a 1 there. So if we're simplifying, it's going to be 3 minus 1, which is x squared, and then 4 minus 1, which is y to the third. Then I can go ahead and I can share the 3 with everything. So everything on the top and on the bottom. So this is going to be 2 to the third, x to the sixth, because we multiply those exponents, y to the ninth, 3 to the third. Oh, hold on one second. And then the last thing I need to do is simplify. The 2 to the third is 8, so x to the sixth, y to the ninth, and 3 to the third is 27. And I can't simplify the 8 or the 27 any further. Now, the biggest misconception that I'm going to see, and that you guys are going to see as you're going through all of this, is that you're going to want to cancel the 3's here in this problem. You can't do that. Okay, you can't go through and cancel the 3's right here. That's not true. And then you'll say the answer is x or x plus 1 over 1. Definitely not true. I'm going to show you why with numbers. So let's say I'm going to plug in a 4. So 4 plus 3 over 3. Okay, what it actually is equal to is 7 over 3. Okay, that is the correct answer. If you try to go through and cancel the 3's, it's going to say it's equal to 4, or 4 plus 1, which is 5, which is not true. All right, so we can't cancel. So what we're going to do instead is we're going to put all the polynomials in standard form. You're going to factor them as far as you can go. Maybe it's just a GCF. Maybe you have to use the British method. It all kind of depends. And then you cancel the same factors from the numerator and denominator. So looking at the first one. Okay, since we've got multiplication going on here, you can cancel the 2's. Okay, whereas in this example up here, I had addition going on between the x and the 3, so that's why we couldn't cancel those. So if I cancel those out, it gives me a 1x over a 1x plus 5, but we don't need those 1's there, so I'm going to kind of erase those 1's. I'm just going to write it as an x over x plus 5, and like we talked before, you can't cancel the x's. Okay, so because of the fact that you've got x plus 5, it's addition, it's together, it's a group. You could also write your answer like this without the parentheses, that's fine. All right, looking at number 6, I'm going to factor out a GCF here for the top. That's going to be 12, and then 2x plus 1 over 3, and then simplify. So 12 and 3 are both divisible by 3. This becomes a 1, this becomes a 4. So it's going to be 4 2x plus 1 over 1, but we don't actually need the over 1 part. So I'm just going to kind of write it like this. Don't distribute, okay? You shouldn't have to distribute at all. Leave your answer factored. It's just one less step that we have to do, okay? We don't have to worry about redistributing and unfactoring. All right, the first one, these look very similar. They're not the same, but they look very similar. Looking at the top one, write it in standard form. So if I write it in standard form, it's a negative x plus 3 over x minus 3. For them to be the same, I need to factor out a GCF here because I have a leading coefficient that's a negative. So if I factor out a negative 1, it leaves me with x minus 3. And then the bottom, if I put that in parentheses, it's x minus 3. You can always put your binomials in parentheses. Now I can cancel the x minus 3. So that was the first example where we could cancel a binomial. So you can cancel a binomial when it's the same at the top and the bottom. So this whole big expression simplifies to negative 1 or negative 1 over 1. Looking at the next one. So you can't cancel the 4s. We've already talked about how we can't cancel the 4s. There's nothing to factor. So this is actually our answer. Okay, we can't simplify that any further. And it's the same thing with this one with the 9s. You can't cancel the x's because the x's are attached to the 5 and the negative 1. If it was both the same, like x plus 5 in the top and the bottom, then you can cancel them. But that's not the case here. So what I'm going to do is just box this answer. That's as far as I can simplify. Looking at the next one, the top, I can pull out a GCF, and my GCF is a 4. It leaves me with x plus 3. Notice I have an x plus 3 at the bottom. Similar, actually exact binomials, so I can cancel the binomials, and I'm just left with a 4. Or technically, it's a 4 over nothing, or a 4 over 1, which simplifies to a 4. All right, looking at this one, if I factor the top, it's add, multiply. So two numbers that multiply to 3 and add to 4 are x plus 3 and x plus 1. The bottom is a GCF. Pull out an x, leaves me with an x plus 1. I can cancel the x plus 1s from the top and the bottom. Leaves me with x plus 3 over x. Done. You can leave your parentheses around x plus 3. Looking at the next one, so if I look at the bottom, I'm noticing that it's not in standard form. So I'm going to write it in standard form, which is a negative 10x plus 5, and then 15x. Then I'm going to factor out a GCF. 15x, pull out a negative 5, leaves me with 2x minus 1. And then now I can simplify the 15 and the 5. That's a negative 1, and this is a 3. So I'm going to write this as 3x over negative 1, 2x minus 1. You could also make the 3 negative up at the top and just write it as 2x minus 1. That's fine too as an answer. Looking at 13, I've got another add multiply. So that's going to be x plus 3. And then the bottom is not in standard form, so I'm going to rewrite it in standard form. Okay, if I rewrite it in standard form, it's negative x squared plus 9. Pull out a negative 1, gives me x squared minus 9, which means I have a negative 1, and this is a difference of 2 squares. So that's x plus 3 and x minus 3. I can cancel only one of the x plus 3s. That's it. Okay, only cancel one of them. So there is an x plus 3 in the numerator, and in the denominator I have a negative 1 and the x minus 3. All right, so for all of these, you are factoring and canceling, factoring and canceling. So looking at this one, this is an add multiply. So two numbers that multiply to negative 4 and add to negative 3 are going to be x minus 3 and x plus 1. And then the denominator, you've got another add multiply. So I need two numbers that are going to multiply to 36 and add to a negative 13. So x minus, no, that's not it. X minus 9, x minus 4. And then I can cancel the x minus 4s from the top and the bottom, and I'm left with an x plus 1 over an x minus 9. Okay, number 15, the bottom is easier because this one's an add multiply. So I need two numbers that are going to multiply to 8 and add to 6. So that's going to be t plus 4 and t plus 2. The top is the British method, so I have to multiply the 2 and the 6 together. I'll do that over here. So that's going to give me 12, two numbers that multiply to 12 and add to 7. So those numbers are going to be 3 and 4. Positive 3 and positive 4, so I'm going to put that inside. So 3t plus 4t plus 6, and then factor by grouping. Pull out a t, 2t plus 3. Pull out a 2, 2t plus 3. So this factors into 2t plus 3 and t plus 2. And then you can see what cancels. It's the t plus 2. So you're left with 2t plus 3 over t plus 4. All right, last thing I want to talk about are the excluded values. So the excluded values are when your rational expression is undefined, when the denominator is equal to 0. You can't have a denominator equal to 0. Okay, that's not possible. So we're going to factor the denominator and set each factor equal to 0. It has to be with the original. See how the directions say the original rational expression? So we're not simplifying anything. We're just setting the denominators equal to 0. So if I set this denominator equal to 0, I get that x can't equal 0, because if x does equal 0, then it's undefined because the denominator is equal to 0. Looking at this one, I'm going to set this equal to 0, add over the 7, add over the 7. X cannot equal 7, because if x does equal 7, then the denominator equals 0. This one I need to factor, so this is an add multiply problem. So this is going to be x has to equal 0, x minus 4, x plus 4, x minus 5 equals 0. Set these individual parts equal to 0, and you're going to get that x cannot equal negative 4 and positive 5. Because if I plug in negative 4, if I plug in positive 5, I'm going to get a 0 in the denominator, and we can't have a 0 in the denominator of our fractions. All right, this is first going to be a GCF here. If I set this equal to 0, so I'm going to pull out an x, leaves me with 4x squared minus 1, and then this ends up being a difference of 2 squares. So this is going to be 2x plus 1, 2x minus 1 equals 0. Set all of my factors equal to 0. I'm going to get that x cannot equal 0, negative 1/2, and positive 1/2. And then the last one over here, okay, just the denominator, set this equal to 0. So this is an add multiply problem. So I need two numbers that are going to multiply to negative 15 and are going to add to 2. So that's going to give me 5 and 3. So that's going to be positive 5 and negative 3. Okay, set these equal to 0. X cannot equal 5, negative 5, and positive 3. All right, guys, I'll see you during the live meeting.